Hello, my name is Jason Aldrich, and I am the Senior Product Manager here at SOR. And I want to thank you for joining us for the latest in our web training series. With today's presentation, we are excited to announce that SOR has added SIL certification to our mechanical product lines. This new feature specifically addresses the growing demand for products designed to meet the needs of today's risk-conscious industrial environments. So today's training is a very basic overview of what SIL is, along with some simple concepts and terminology you might need when discussing this feature with your customers. It's not meant to be an exhaustive lecture on the SIL standard, but rather something to help familiarize you with some of the more elementary functions and buzzwords that you might hear in a conversation about SIL. Well, this presentation can get a little bit technical, but we're going to do our best to keep it short. And really, what we want you to get out of this is just that you come away a little bit more familiar with the words and some of the concepts, so that when you talk to your customers or your customers talk about it with you, you can say, yeah, they're talking about SIL here. So you can go down that path, you can get them the proper literature, certificates, etc., and you can just basically point them in the right direction. So we're going to start out by talking about the standard itself and its components, and then kind of move into a brief explanation of how SIL values are derived, and then on to some other helpful information. So in short, SOR has completed the necessary steps to get SIL ratings for all of our mechanical products. The one exception to this is the pneumatic operated devices, which don't actually require any SIL approval. Well, most of our products carry a SIL 2 rating, but a few were only able to achieve a SIL 1 rating, and we're going to go into that in just a little bit. But suffice it to say, probably 99% of our products were rated to a SIL 2 rating. The information in this presentation is important for everybody to know, because SIL is not a project-only specification. I know a lot of times it gets talked about more alongside projects, but MRO and OEM customers have also requested this rating, so it's important to get the word out to them about this addition as well. You might run into SIL requirements in a lot of different industries, but you need to pay particular attention if your customers are in the chemical or petrochemical or oil and gas business. So with that in mind, let's get started. SIL is handled under IEC code 61508. And I know that sounds intimidating, but you don't necessarily have to remember this number. But 61508 is actually a kind of umbrella standard for functional safety across several industries. So by complying with IEC 61508, a company is complying with all of the industry-specific safety standards, such as codes that handle the process industry, the nuclear industry, or machining industry, just to name a few. So how does it work? Well, these standards are designed to address the entire safety life cycle, so from the very beginning installation all the way to removal. And they're based on analysis of performance and of key components within the system. So bottom line, these codes are written to help companies reduce risk by looking for the weakest link in a process. Again, it doesn't guarantee safety, but it is simply reducing the risk. If we dig a little deeper, we see that SIL is actually only one part of a greater puzzle. In fact, IEC 61508 defines three successive tiers, if you will, of safety assessment. So you may have heard of some of these terms. They may have been thrown around for a while, and yes, they do all relate to SIL. But it's composed of safety instrumented systems, safety instrumented functions, and the safety integrity level. So the first level is safety instrumented systems. A safety instrumented system, or SIS as it is abbreviated commonly, is defined as an instrumented system used to implement one or more safety instrumented functions. It is made up of any combination of things like sensors, logic solvers, etc. So basically, this is the overarching system. This is the whole system that is composed of safety instrumented functions, as we saw in the graphic on the last slide. In essence, the SIS is an instrumented control system that detects out of control conditions and automatically returns the process back to a safe state. Again, this is a system, and the entire system must work together to reduce risk by bringing the individual elements back to a safe state when necessary. So the second level is safety instrumented functions. And a safety instrumented function, or SIF, is defined in the IEC code as a function to be implemented by a SIS, or the system itself, which is intended to automatically achieve or maintain a safe state for the process with respect to a specific hazardous event. Basically, the SIF is an independent safety loop, or an interlock, that automatically brings processes to a safe state in response to specific events. Here we have a component of the larger SIS, which is responsible for bringing its particular control group back to a safe state. So this is nested underneath of the SIS. So you can think of this is all like a system, and then maybe there's even a subsystem underneath of that with the SIS and the SIF underneath of that. So now we're really starting to kind of see a picture form, which brings us back to our topic of the day, which is, of course, SIL. So that third level is safety integrity level. The safety integrity level, or SIL, is the safety integrity level of a specific safety instrumented function which is being implemented by a safety instrumented system. So once again, we see that successive tier type mentality continuing here with SIS, then SIF, then a SIL analysis underneath of that. So in other words, SIL is a measure of risk reduction provided by a specific safety instrumented function. Each device required to perform a safety instrumented function must have a SIL value assigned to it that's appropriate to the risk that's assigned to the entire system. So what you have is the system and the conditions that it is exposed to or has to operate under, and that will dictate what the necessary SIL value needs to be of those safety instrumented functions underneath of it. So as we said, the whole process is simply about eliminating or reducing risk. IEC defines risk as the likelihood of a defined consequence occurring within a known period or under specific conditions. This particular calculation is a relatively simple equation that just multiplies the probability of harm and the severity of that harm to come up with that risk factor. You can see from the graphic here that as either probability goes up or severity goes up, so does your risk. So risk equals probability times severity. Again, a relatively simple equation, but unfortunately the other equations necessary to determine a SIL value aren't quite that simple. And so we're just going to touch on a few of those factors to get you familiar with the terminology, but we're not going to go into all the equations that factor into determining that final SIL value. All that's really essential for you to know is that SIL values are expressed as a number from 1 to 4, with SIL 4 providing the greatest risk reduction and SIL 1 providing the lowest risk reduction. As I said, there's many complex factors that figure into this determination, but I do want to at least mention a few of the key players. You can see in this table that SIL level is gathered from a number of sources. The left table shows the SIL requirement based on a probability of failure on demand. This is a fairly self-explanatory measure of how likely the instrument is to fail when called upon to respond to a safety situation. The right table shows the SIL requirement based on something called a safe failure fraction. And so a safe failure fraction is the resulting percentage from a much more complex equation that indicates the probability a component will fail in a safe state. So if you've got one state that's safer than another in regards to the overall system operation, then you want your system to fail, if it fails, into that state. Now, a lot of analysis and computations go into determining things like probability of failure on demand and safe failure fraction. You probably don't need to know all of this kind of thing for everyday sales, but I've put a couple other things here also that you might get asked about along the way. One of those is demand mode. That's something you may have noticed on the last slide in relation to PFD. But demand mode is a classification based on how often the component will be called upon to work. So obviously there's more risk associated with something that has to operate 10, 20, 30 times a day or more versus something that gets called upon to operate once a year. Some applications are low demand mode and some are high, and all of that factors into how customers will calculate what SIL level is necessary for an instrument. An FMEDA report is a report that outlines the details of all the component testing whereby a resulting SIL level was achieved. That's something that customers are likely to ask about from time to time. Honestly, it probably has more detail than most customers will need. We have a couple other resources that can get them the more critical numbers in a more understandable fashion, but you will on occasion find people that want an FMEDA report, and we are able to provide these reports, but like I said, most customers will find the information contained in our literature helpful enough to get them the answers that they need. So, just to recap, this was only meant to be a very brief introduction to SIL and what we have to offer, but I would like you to walk away remembering just a few of these things here. Most SOR products carry a SIL 2 rating. Again, that's a vast majority, probably like 99% of our products. But there were a few that were not able to get a SIL 2 rating, and that's because they aren't offered in a DPDT configuration. Products that are not available in DPDT configuration can only achieve a SIL 1 rating because of some of the redundancy requirements and the calculations that go into this analysis. Answers to most customer questions can be found in a very helpful little piece of literature that our marketing department here at SOR has put together, and it's called the Safety Integrity Level Quick Guide. It's form number 1528. You can get it from the website, and I highly encourage you to read this as soon as you can. It goes into SIL a little more in depth than this presentation did. It also has charts that show all of the products and their corresponding SIL values, along with some of the more commonly used values such as PFD, etc., that people might need to plug into their system calculations. So again, I encourage you to go to the website, download the quick guide, read it through. That really should be your frontline defense when customers are asking about SIL. You really do need to get this document in their hands. It will answer a vast majority of their questions. Beyond that, we do have SIL certificates, and they're available for all the qualified products. We have one cert for our pressure products and one for our level products. Those also have good information on them that they need when calculating values for their safety analysis. And some customers just want a formal certificate to put in their records when they purchase a product that's SIL rated. And like I said, FMEDA reports can also be produced on request. Again, these are very technical. It also involves some work here at SOR to produce them. So they should really be a very last resort and probably only be offered when the customers are asking for them specifically by name. So, as always, if you have any questions or need assistance in ordering, please contact your SOR customer service representative. I really hope this presentation's been helpful. This is going to be on our site for quite a while, so if you want, please feel free to refer back to it in the future. Thank you for attending and have a great day.